Okay, we're looking at level 1. We're looking at geometrical reasoning, and I believe I've done a video on that. And I think I've done a video on question 2. Okay, so let's look at question 3. Okay, so PR. So, oops. PR is that line there. And QR is that line there. The same length. So that's the same length as that. Which means that that angle and that angle are going to be the same, because that's an isosceles triangle. And base angles are equal. Okay? Angle RQS. So where's RQS? That's X. That's angle X. Okay? Is X? Oh, okay, yes it is. Right? RT is parallel to PS. So RT that line through here is parallel to QS. PS, same difference. Parallel. So we've got parallel lines. This one and this one are going to add to 180 because they're co-interior. These two are going to add up to 180, aren't they? Because the angle's on a straight line. These two are equal. So if you like, if that's X, then this is 180 minus X, and that's 180 minus X. Okay, so what does it make this one? Anyway, let's look at what the question is. If X is 110, find PRQ. So PRQ is this one here. So if that's 110, we need to find out what this is. So we need to do our reasoning, and it's really good to label the angles. So the calculation, I'm going to go step by step. RQS angle equals I was going to say 180 minus angle PQR, but it would have been better to have written angle PQR equals 180 minus angle RQS, and I'm going to write angles on a straight line add to 180. So that's going to equal 180 minus 110, which equals 70. Okay, then I'm going to go PQR equals QPR. Okay, so angle PQR equals angle QPR. That's base angles isosceles triangle, and then I've got angle PRQ equal 180 minus angle PQR minus angle QPR, which equals 180 minus 70 minus 70, and so that's 140, so that equals 40. And what's my reasoning? Angles in a triangle add to 180. Okay, let's have a look at the answer scheme. Going to question 3. And we've got QP, RPQ, angles on a line, base angles isosceles, and angles in a triangle. Find that correctly giving a coherent explanation of the geometrical reasoning with 3 steps. So you need those 3 steps. That's cool, no problem there. Alright, now the next one. Prove PRT and RQS are equal for all values of x. So if I just go to this one here, I've actually more or less done it. That instead of saying 10, I actually had that. Okay, angle QRS. So you can actually do that same reasoning and labelling the whole way through. Okay, so a little bit of algebra coming in there as well. But it's the same reasoning, it's just generalisation. Okay, nice little bit of, if you get your algebra right, by algebra I mean you've got 2 lots of 180 minus x. Okay, that kind of thing. Next one. Ah, nice. Nice diagram. Okay, it's a cyclic quad. Fine. Angle EDG is 82. So in a cyclic quad, these two, what's the rule? Add to 180, so that has to be 98. Okay. O is the centre. Find the angle HFJ. HFJ, so you've got 2 reasonings. Your first reasoning, these are opposite angles in a cyclic quad, add to 180, and then the next reason is that EFG, this angle here, must equal HFJ because vertically opposite angles are equal. So opposite angles in a cyclic quad add to 180 and vertically opposite angles are equal. Okay, coherent. That's cool. So that's all right. And next question. Points line the circumference of the centre. AQ is parallel. AQ is parallel to NZ. Find the size of NZQ in terms of x. So NZQ is that angle there. So I'm finding it in terms of x. Okay. So I find it easier to think if I look at that way, and I can see that these two are co-interior. So NZQ, angle NZQ, plus angle AQZ equal 180 because they are co-interior parallel lines. They add to 180. These two also add to 180. Okay, and what's the reason there? Opposite angles in a cyclic quad. So if these two add to 180 and these two add to 180, then this must be x, surely. These two add to 180, these two add to 180. So NZQ, I'm thinking is x. NZQ is x. So we've got our co-interior angles, and then we've got opposite angle cyclic quad. Okay, coherently. So you need to explain it nicely. Okay. What angle properties does a cyclic parallelogram have? Explain your answer with geometrical reasoning. Use the blank diagram if you wish. So a parallelogram. Oh, it's interesting, isn't it? Think what a parallelogram is, and it's got to be like that, doesn't it? So if these opposite ones are adding to 180, and if that has got to be parallel like that, surely you're going to end up with the fact that it actually has to be a rectangle, otherwise it won't work. Need to have 90 degrees at each corner, since it's a cyclic trapezium, so the relationships must hold. In addition, adjacent corners are co-interior and they must add to 180. This means that x and 180 minus x must be equal, so x has to equal 90. Hence, a cyclic parallelogram must be a rectangle and have right angles at each corner. Okay, explaining using clear logical geometrical reasoning with a cyclic parallelogram must be a rectangle. So knowing it like intuitively, working it out, is not enough. You actually have to have a logical explanation, and this is a good hint. Okay, so if these two are x, and these two, if you've got a parallelogram, that one has to be parallel with that one. So how are you going to make those two parallel? They're going to have to be 90. Okay, given the constraint. It might be easier sometimes to do a counter example.